For centuries, sailors spoke of monsters at sea, not creatures with teeth or claws, but waves so tall they could swallow ships whole, rising out of calm oceans without warning, striking with the force of a natural explosion. They called them freak waves, killer waves, or rogue waves, and for most of modern history, science said they were impossible. Imagine standing on the deck of a cargo ship in the middle of the Atlantic. The sea is calm. Winds are low, the sky is clear. Then suddenly, out of nowhere, the horizon darkens. A single wall of water, 30 meters high, surges toward you. For centuries, this was the nightmare whispered by sailors and dismissed by scientists. The reason? It didn't fit the math. According to traditional ocean models, waves of that size should occur once every 10,000 years. But ships were vanishing far more often than that. Logbooks spoke of waves as tall as a 10-story building, smashing into oil platforms, ripping steel apart, and disappearing back into the ocean before anyone could believe what they'd seen. The turning point came on New Year's Day, 1995, in the icy waters of the North Sea. At the Draupner oil platform off the coast of Norway, engineers were monitoring wave activity with a laser sensor. At exactly 3 o'clock in the afternoon, the data spiked. A single wave, rising 25.6 meters, struck the platform. The wave's impact shattered windows and bent steel, but the platform survived, and the sensor recorded everything. That moment would become known as the Draupner wave, the first scientifically proven rogue wave. The myth had just become measurable reality. Rogue waves are not tsunamis. They're not caused by earthquakes or underwater landslides. They're born purely from chaos, the interference of normal waves combining at just the right time and place to create a monster. Picture the ocean as billions of tiny ripples moving in every direction. Sometimes, by sheer chance, multiple waves line up perfectly, each adding energy to the next. When that happens, a single massive wave forms, towering 2 or 3 times higher than anything around it, before collapsing seconds later. These events are now known as nonlinear wave interference, a reminder that the ocean doesn't always play by human rules. In 1978, the German cargo ship München disappeared in the North Atlantic. It was one of the most advanced vessels of its time, designed to withstand the harshest storms. When wreckage was later found, the lifeboats had been ripped from their mountings, 18 meters above the waterline. Investigators were baffled. Only decades later, with the rogue wave theory proven, did the pieces finally fit. In 2001, the cruise ship Bremen was struck by a 30-meter wave off Antarctica. Its windows shattered, power failed, and the ship drifted helplessly for hours before regaining control. Passengers described it as being hit by a moving wall. The same year, the Caledonian Star faced a similar wave, again around 30 meters. 2 ships, 2 encounters in the same ocean within weeks. Coincidence? Hardly. After the Draupner incident, scientists launched satellite missions to monitor the open ocean. They expected to find maybe 1 or 2 rogue waves per decade. Instead, they found dozens happening every week. In 2004, the European Space Agency SERS-1 satellite confirmed more than 10 giant waves over 25 meters tall within just 3 weeks of observation. The data was undeniable. Rogue waves were not rare, they were everywhere. Oceanographers had to rewrite their models from scratch. The sea, it turned out, was far more unpredictable and far more dangerous than we'd ever realized. So how can something that shouldn't exist happen so often? The answer lies in energy focusing. Under certain conditions, wind, current, and wave direction can combine to funnel energy into a single crest. This is known as modulational instability, the same principle behind lasers, but in water. It's the ocean amplifying itself. The mathematics of rogue waves borrow from quantum mechanics and chaos theory. They are the sea's version of a black hole, rare, short-lived, and immensely powerful. Today, rogue waves continue to challenge ships and oil platforms across the globe. In 2020, a buoy off Canada's coast recorded a 17.6-meter wave in seas where typical waves were just 6 meters. Statistically, that's a once-in-4,000 years event, yet it happened again only months later on the opposite side of the Pacific. Modern ships now carry reinforced hulls and radar that can detect rogue waves minutes in advance. Still, no amount of technology can fully protect against nature's raw power. Some of these waves rise so fast they seem to defy physics, a reminder that the ocean remains the last true wilderness on Earth. What was once dismissed as superstition has now become a field of cutting-edge research. Scientists at the European Marine Laboratory now simulate rogue waves in giant tanks, studying how they form and how to predict them. Supercomputers crunch terabytes of ocean data, trying to forecast when and where the next one will strike. The ultimate goal is to make shipping and offshore energy safer, but the deeper scientists dive into the math, the clearer one truth becomes. Rogue waves are not an anomaly. They're part of the ocean's natural rhythm, a brutal reminder of its chaotic beauty. For sailors, the legend of the rogue wave was never a mystery, it was a memory. Every survivor's story shares the same tone: awe, fear, and disbelief. A calm ocean turning into a vertical wall, a sound like thunder when water hits steel. Then silence. It took modern science centuries to believe what ancient sailors already knew. The sea can create monsters, not from myth, but from mathematics. In 1995, when the Draupner wave struck and data finally confirmed the impossible, one oceanographer said, "Nature doesn't read our textbooks." That quote still defines the mystery of rogue waves. They're proof that even in the age of satellites and simulations, we haven't tamed the planet. We're just beginning to understand it. Every time you look at the ocean, remember, beneath that calm surface lies an infinite orchestra of forces, capable of creating a wall of water that defies reason and redefines fear. The rogue wave is more than just a giant wave. It's the ocean reminding us that it's still in charge. If you enjoyed exploring the science and mystery of rogue waves, make sure to like this video, subscribe for more deep-sea discoveries, and share it with someone who still thinks the ocean is predictable. Because as we now know, the sea always keeps a few secrets beneath the surface.